Today in geometry, we looked at the distance formula in 1 dimension and in 2 dimension. So I will go share my screen and we'll look at the whiteboard and I'll show you what we talked about in class. When you're looking at distance formula in 1 dimension, so we have a line here and we can create a whole bunch of points on this line. Let's just make some tick marks here. 1, 2, 3, 4, 5. Going back the other way. 1, 2, 3, 4, 5. So this point right here would be 0. This would be -2. This would be -5. Let's call this point A. So this is A. This would be B. This would be C. We can put D here. And we can put E here. So E is 5. And D is 2. Now if you remember, if I type in, I can do this with text here. If I type the letter, let's say B, E. B-E. Remember, no symbol on the top. There's no line. There's no double stemmed arrow. So what this means is the length of BE. So if I go back here, I can put my equal sign. Put my equal sign. And what I get when I'm doing the length is I get the rightmost points. So the rightmost point is 5 minus the leftmost point. Now the leftmost point is -2. So 5 minus a -2 is 5 plus 2, which is 7. Okay. So normally you do the right point minus the left point, but you can also put this in absolute value and it doesn't matter. So I do -2, which would be the left point, minus the right point. And if I put these together, I get the absolute value of -7, which is 7. Okay, now, so that's 1-dimensional distance. So if I erase this, remember you can pause this video anytime if you want to just kind of freeze and look at something. So you could pause this at this time. So I take my eraser and I erase the whole thing, right? Now, so now we're going to go to 2 dimension. So we'll draw our axis. Let's come in here like this. And then 2 dimension, what we have to do, let's say we have a point. We have a point here, which is, let's say, 1 and 1. And we have a second point up here, let's say, which is 6 and 5. Okay, now, so I'm looking at the length of the line that goes from here to here. Now, so I will let this point up here be P2. And I will let this point down here be P1. Now, that makes this x2, and the 5 is y2. And that makes this down here x1 and y1. Okay, now the distance formula in 2 dimensions says d equals the square root of, so I got a square root here, of x2 minus x1 squared plus y2 minus y1 squared. Okay, now, so all I do is substitute in the right number in the right spot. So I got the square root here. x2 is 6. So I got 6 minus x1, which is 1, squared, plus y2, which is 5, minus y1, which is 1, squared. So what I get here is 6 minus 1 is 5, and I square it, so I get 25. And 5 minus 1 is 4. I square that, so I get 16. And 25 plus 16 is the square root of 41. Now that's a little bit more than 6 because the square root of 36 is 6, and it's a little bit less than 7 because the square root of 49 is 7, okay? So if you look in your textbook now, there's an example problem that's worked out here, and you can see the derivation of this formula there, okay? Now, if you remember, when you're looking at something like this, it basically, all you're doing is, if you remember the Pythagorean theorem, which says a squared plus b squared equals c squared, then that's all we're doing here, because see, this side here, if you go from 1 to 6, this is 5. And if you go from this one here in the y direction up to 5, that's 4. So all you're doing is side squared plus side squared equals, and this over here is distance. So that's just basically a special use of the Pythagorean theorem, okay? So we'll stop sharing here. If you have any questions after you look through your homework, please send me those in an email and I will get back to you.